Meeting cooling requirements in a Division 1 Class 2 environment with NEMA 7 enclosures requires careful consideration of safety and performance. Several methods can be employed to effectively manage heat within these enclosures. Firstly, consider utilizing closed-loop liquid cooling. Install a heat exchanger outside the enclosure and circulate a dielectric liquid through the enclosure to absorb heat. The heat is then dissipated by the heat exchanger, reducing the internal temperature. Secondly, employ air-to-air heat exchangers. Install an air-to-air heat exchanger that transfers heat from the inside of the enclosure to the outside atmosphere. A fan circulates air through the heat exchanger, cooling the enclosure. Thirdly, implement purge and pressurization. Introduce a continuous flow of clean air into the enclosure, creating positive pressure inside. This pressurized air prevents flammable vapors or gases from entering the enclosure and reduces heat buildup. Fourthly, use air conditioners. Install air conditioners that cool the air within the enclosure. Ensure that the air conditioners are explosion-proof and meet the NEMA 7 requirement. Fifthly, utilize vortex coolers. Employ vortex coolers that use a high-velocity airstream to create a vacuum inside the enclosure. This vacuum draws in cool air from outside, reducing the internal temperature. Sixthly, consider heat sinks and thermal compounding. Install heat sinks on heat-producing components to dissipate heat directly. Apply thermal compound between components and heat sinks to improve heat transfer. Seventhly, implement thermal barrier coatings. Coat the inside of the enclosure with a thermal barrier coating that reflects heat away from the enclosure interior. Eighthly, select appropriate materials. Use materials with low thermal conductivity, such as stainless steel, to minimize heat transfer into the enclosure. Additional considerations include ensuring that the cooling solution is compatible with the equipment inside the enclosure. Consider the environmental conditions, such as temperature and humidity, when selecting the cooling method. Regularly inspect and maintain the cooling system to ensure proper functionality. Comply with all relevant codes and standards, including National Electrical Code, NEC, and National Fire Protection Association NFPA 70. The selection of an appropriate cooling method depends on the specific heat load, environmental conditions, and available space. Always prioritize safety and compliance with relevant standards. When employing closed-loop liquid cooling, the dielectric liquid must be compatible with the electrical components inside the enclosure and possess the necessary thermal properties for efficient heat transfer. The heat exchanger should be sized appropriately to handle the maximum heat load generated by the equipment within the enclosure. Air-to-air heat exchangers are a passive cooling solution that can be effective in environments with moderate heat loads. The efficiency of the heat exchanger depends on the temperature difference between the inside and outside of the enclosure, as well as the airflow rate. Purge and pressurization systems are commonly used in hazardous locations to prevent the accumulation of flammable gases or vapors. The airflow rate must be sufficient to maintain positive pressure within the enclosure and prevent the ingress of hazardous substances. Air conditioners provide active cooling and can be used to maintain a consistent temperature within the enclosure. Ensure that the air conditioner is rated for use in hazardous locations and that it is properly sized to handle the heat load. Vortex coolers are a simple and reliable cooling solution that uses compressed air to generate cool air. The cooling capacity of a vortex cooler depends on the pressure and flow rate of the compressed air. Heat sinks are a passive cooling solution that can be used to dissipate heat from individual components. The size and material of the heat sink should be chosen to maximize heat transfer. Thermal compound is used to improve the thermal contact between components and heat sinks. Apply a thin, even layer of thermal compound to ensure optimal heat transfer. Thermal barrier coatings can reduce the amount of heat that enters the enclosure from the surrounding environment. The coating should be applied to the inside of the enclosure to reflect heat away from the interior. The material used for the enclosure should have low thermal conductivity to minimize heat transfer. Stainless steel is a common material used for NEMA 7 enclosures due to its durability and corrosion resistance. When selecting a cooling method, consider the maintenance requirements. Some cooling systems require regular cleaning and maintenance to ensure proper operation. The environmental conditions can also affect the performance of the cooling system. High temperatures and humidity can reduce the efficiency of some cooling methods. Always consult with a qualified engineer to determine the best cooling solution for your specific application. Proper cooling is essential for ensuring the safe and reliable operation of equipment in hazardous locations. Failure to properly cool the enclosure can lead to overheating, equipment failure, and potentially hazardous conditions. The NEC and NFPA 70 provide detailed requirements for electrical equipment installed in hazardous locations. It is important to comply with these requirements to ensure the safety of personnel and property. The selection of a cooling method should also consider the cost and energy efficiency. Some cooling systems are more expensive to install and operate than others. It is important to choose a cooling system that is both effective and cost-efficient. Regularly inspect the cooling system for any signs of damage or malfunction. Repair or replace any damaged components immediately. Keep the enclosure clean and free of debris to ensure proper airflow. Monitor the temperature inside the enclosure to ensure that it is within the acceptable range. Implement a preventative maintenance program to ensure the long-term reliability of the cooling system. Document all maintenance activities and inspections. Maintain records of all cooling system components and their specifications. Provide training to personnel on the proper operation and maintenance of the cooling system. Ensure that personnel are aware of the hazards associated with working in hazardous locations. Follow all safety procedures and guidelines when working on the cooling system. Use appropriate personal protective equipment, such as gloves and eye protection. Energize the equipment before performing any maintenance or repairs. Verify that the enclosure is properly grounded. Properly dispose of any waste materials generated during maintenance or repairs. Consider the use of remote monitoring systems to track the performance of the cooling system. Remote monitoring systems can provide early warning of potential problems. Implement alarms to alert personnel of any abnormal conditions. Regularly review the performance data to identify trends and potential issues. Use the data to optimize the performance of the cooling system. Consider the use of energy-efficient cooling technologies. Energy-efficient cooling technologies can reduce operating costs and environmental impact. Implement a comprehensive energy management program. Continuously evaluate the performance of the cooling system and identify opportunities for improvement. Stay up to date on the latest cooling technologies and best practices. Consult with industry experts to get advice on the best cooling solutions. Participate in industry conferences and training events. Read industry publications and technical articles. Network with other professionals in the field. Share your experiences and best practices with others. Contribute to the development of industry standards and guidelines. Promote the importance of proper cooling in hazardous locations. Advocate for the use of safe and reliable cooling technologies. Support research and development efforts to improve cooling technologies. Work with regulatory agencies to ensure that cooling systems are properly designed and installed. By following these guidelines, you can ensure that your NEMA 7 enclosures in Division 1 Class 2 environments are properly cooled and that the equipment inside operates safely and reliably. Remember that safety is always the top priority. Take the time to properly design, install, and maintain your cooling system. Consult with qualified professionals to ensure that you are meeting all applicable codes and standards.